Lucky, you need to unmute.
Good evening, everyone. Hope you all are staying safe. Welcome to the seminar on Climate Smart Agriculture and Sustainable Development Goals. I am Muhammad Lucky, lecturer, Department of Farm Power and Machinery. It's my great honor to welcome you all in today's seminar. I am truly humbled by the opportunity to moderate the session in such a distinguished group of scholars and professionals. In the seminar, we are really glad to have Dr. Chayan Kumer Saha, sir, Associate Director, ASMIH-Bangladesh Phase 2 and Professor, Department of Farm Power and Machinery, Bangladesh Agriculture University, as a distinguished speaker in today's seminar. We are also very glad to have Dr. Monjurul Alam, sir, Project Director, ASMIH-Bangladesh Phase 2 and Professor, Department of Farm Power and Machinery, Bangladesh Agriculture University, as a present as the discussant. Some housekeeping announcement. Please keep your microphone mute until you speak in this session. If you have any question or suggestion during the program, you may put your question in the chat box. You may turn off your video for better streaming or saving the megabytes of data if you are connected via cell phones. The meeting is being recorded. Hope there should not be any problem from your side. This seminar is arranged by Smart Agro-Technology Innovation Youth Network, SAIYN, which is an initiative of the Appropriate Scale Mechanization Innovation Bangladesh, based at Department of Farm Power and Machinery, Bangladesh Agriculture University, Bangladesh. SAIYN is a knowledge-based learning platform for youth where they can explore their and boost their interest on smart and innovative agro-technologies for sustaining agricultural production, processing, and food and nutrition security. This is principally a youth-based network focusing on youth, agro-entrepreneurship, and empowerment. The vision of SAIYN is that SAIYN is to be a driving force to connect teenagers and youth around the globe to be the future leader in smart and innovative agro-technologies. Engage and empower them to nurture their capabilities and contribute to positive agricultural transformation. The SAIYN works with 5 missions, which are 1. SAIYN connects teenagers and youth through networking, notify and motivate them through sharing knowledge and awareness building program on smart and innovative agro-technologies. Number 2 is SAIYN engages youth in a meaningful way through providing opportunities and collaborative undertaking on innovative agro-technologies. Number 3, SAIYN empowers young people through capacity building events on smart agro-technologies. Number 4, SAIYN creates an entrepreneur culture among youth so they can choose an agro-technology-based career path after their graduation. And number 5, SAIYN seeks partnership and collaboration to work in a synergistic manner towards a culture where teenagers and youths are cherished, valued, and regarded as an essential human capital for positive agricultural transformation. SAIYN arranges seminar series, and today seminar is a part of the seminar series. Persistent food security, a growing world population, accelerating global warming, and its impact on agriculture make the climate smart agriculture approach even more relevant. On the other hand, the United Nations 2030 Agenda for Sustainable Development includes 17 Sustainable Development Goals and 169 targets provides a universally accepted and comprehensive framework addressing all respected aspects and dimensions of sustainability. The integration of the climate smart agriculture approaches with implementation of the 2030 agenda provides an opportunity to enhance the overall sustainability of climate smart agriculture, resulting and synergize climate agriculture, smart agriculture interventions with other sustainable development efforts. Today's speaker will provide some overview on climate smart agriculture approaches, its sustainable development goals, and how the climate smart agriculture implementations processes can engage with the 2030 agenda. Dear participants, now it's time to hear from our keynote speaker. Our keynote speaker is Dr. Chayan Kumer Saha. He is a professor at Department of Farm Power and Machinery, Bangladesh Agricultural University, Bangladesh, where he has been involved in teaching and research for last 22 years. He is an expert in providing appropriate scale mechanization and renewable energy solutions in crop and livestock production and processing. Recently, he is working on circular food system for achieving sustainable development goals in Bangladesh. He has been involved in researches nationally and internationally. It is my honor to invite Professor Dr. Chayan Kumer Saha for his presentation.
Thank you, dear moderator, for your nice words. Dear colleagues, academicians, researchers from internal and from outside country, dear SAIYN ambassadors, students, I'm welcoming you all in my presentation. Can you hear my slide? Can you see my slide?
Yes, sir.
Okay. So thank you. My presentation title is Climate Smart Agriculture and its relation to Sustainable Development Goals. Idea of giving this presentation to aware our youth about climate smart agriculture and how this climate smart agriculture has been linked to sustainable development goals. So outline of my presentation, you can see I will provide some background and I will talk about climate smart agriculture and what are the sustainable development goals, how these SDGs are linked to circular food system and climate smart agriculture, and then there will be some conclusion and remarks. As you know, our Bangladesh has a population of 168.22 million in the area of 1,47,570 square kilometer, and employment by sector you can see in agriculture 40.6% right now. And among the area that we have cultivable land only 59.83%, where actually 70% of this 59.83% is being used for the rice production, and also we produce huge amount of fruits and vegetable in limited lands, as well as livestock and fisheries. We can proudly say that we are fourth largest rice producer in the world. We have attained self-sufficiency in the paddy production. We are third largest vegetable and inland water fish producer, fifth largest aquaculture fish producer, and self-sufficient in meat and egg production. On the other hand, if we look at our production system, our agricultural production system is linear, where in linear economy, food and agriculture production system have losses, waste along the full value chain. We would define input resources like land, water, energy, nutrient, labor, and capital we are using in pre-production, production, post-harvest operation, as well as in the consumption pathway. We can see that in the linear system, there are huge losses and waste of the input, as well as we have also a huge amount of fruits, vegetables, rice loss, production loss also. Because of this loss and in the linear production system, agriculture is contributing 39% of greenhouse gas emission in Bangladesh. And beside that, there are also greenhouse gas emission from fossil fuel-based energy system, waste management system, industrial process. In the agricultural production system, we can see that mostly the greenhouse gas emission is coming from rice cultivation, enteric fermentation of the dairy. Also, there is the emission from the manure left on the pasture, burning from the crop residues, synthesize use of synthetic fertilizers. So all are contributing in the greenhouse gas emission. So these greenhouse gas emissions from our country as well as from the developed countries, the temperature of Bangladesh is changing, it will be changed, and you can see in 2030 it will be average temperature will increase 1.2 degree. In 2050 it will be, if the trend remain the same, it will be 1.7, and 2070 it will be 2.1 degree increase in for average temperature. At the same time, the precipitation rainfall will be increased from 9 to 12%, depending on the where we are located in Bangladesh. So this may causes cyclone, natural disaster like flood, and we may have problem with the salinity. And that in that case, we have to compromise with the agricultural productivity and economic development. So that means we have to think alternative. World is already thinking, and world is now transiting toward more circular system. In circular economy system, it says that we need to keep product and material in use, design out waste and pollution, regenerate natural systems. And key outcome of transitioning of circular system are increased sustainable resource efficient system with less waste. So what we can see here, so resource efficiency system with the less waste. That means here is the climate smart agriculture come in the picture, which may help to achieve the sustainable development goals by 2030. So what is climate smart agriculture? Climate smart agriculture is defined by World Bank is saying is an integrated approach to managing landscape, cropland, livestock, forest, fisheries that address in the interlinked challenges of food security and climate change. FAO defined climate smart agriculture an approach that helps guide action to transform agri-food system towards green climate resilient practices. And this CSA support reaching nationally, internationally agreed goals such as SDGs and the Paris Agreement. On the other hand, ASEAN, CRN, they have defined this climate smart agriculture as an approach for transforming and reorienting agriculture system to support food security under the new realities of climate change. So that means we have to be climate smart. We have to transform and reorienting our agriculture system to sustain or attain the food security in the new realities of the climate change. So this climate smart agriculture has three pillars. The pillar one is saying that sustainability, increase of agricultural productivity and income by increasing resource use efficiency, diversify production system, manage ecosystem services and biodiversity. Pillar two is saying the build resilience and adapt to climate change by introducing diversified production system, planning production activity to reduce risk exposure, sensitivity, and adapt to changing condition, and manage ecosystem services and biodiversity. CSA pillar 3 is saying that we need to reduce and or remove greenhouse gas emission where possible by increasing resource use efficiency, by retaining and sequestering carbon in agro-ecosystem, replacing fossil fuel-based energy with renewable energy. So these are the three pillars to move forward to climate smart agriculture. So we need to remember these three words: productivity, adaptation, reduce efficient use of the resources, replacing of the fossil fuel, carbon sequestration, and the diversity of the production system. On the other hand, in 2015, 195 nations agreed with the United Nations that they can change the world for the better. The Sustainable Development Goals, also known as the Global Goals, were adopted by the United Nations in 2015 as a universal call to call to action to end the poverty, protect the planet, and ensure that by 2030 all people enjoy peace and prosperity. These 17 SDGs are integrated. They recognize that action in one area will affect outcome in other, and that development must balance social, economic, and environmental sustainability. And this 17 SDGs has 169 target and 232 indicator for achieving this goal. These are the 17 sustainable development goals. I'll go through quickly with each of the goals. Goal one saying no poverty. That means we need to end the poverty in all its form everywhere. Goal two is zero hunger, that we need to end hunger, achieve food security, improve nutrition, and promote sustainable agriculture. Goal three goes with the good health and well-being, ensure healthy lives, promote well-being for all at all ages. And also Sustainable Development Goal 4 is saying that quality education. So ensure inclusive and equitable quality education and promote lifelong learning opportunities for all. Goal 5 is a gender equality. So achieve gender equality and empower all women and girls. Clean water and sanitation is goal number 6, where we need to ensure availability and sustainable management water and sanitation for all. Affordable and clean energy is goal 7, where we need to ensure access to affordable, reliable, sustainable, and modern energy for all. And goal 8 is a decent work, economic growth. That means we need to promote sustainable, inclusive, and sustainable economic growth, full and productive employment, and decent work for all. Goal 9 is industry, innovation, and infrastructure, where we need to build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. Goal 10 is reduce inequalities. We need to reduce inequality within and among the countries. And goal 11 is sustainable cities and communities. So we need to make cities and human settlement inclusive, safe, resilient, and sustainable. 12 is responsible consumption and production. So we need to ensure sustainable consumption and production pattern. 13 is climate action, where we need to take urgent action to combat climate change and its impact. And 14 is life below water, where we are saying we need to conserve and sustainably use the oceans, seas, and marine resources for sustainable development. And 15 is life on land, where we need to protect, restore, promote sustainable use of terrestrial ecosystem, sustainably manage forest combat desertification, and halt and reverse land degradation and halt biodiversity loss. And 16 is peace, justice, and strong institution. So we need to promote peaceful, inclusive societies for sustainable development, provide access to justice for all, and build effective, accountable, and inclusive institutions at all levels. And finally, the 17 is partnership for the goals. So it's saying that strengthen the means of implementation and revitalize the global partnership for sustainable development. So it emphasizes global partnership for our sustainable development. In one of the study, Rockstrom and Shukdev, they showed these 17 sustainable development goals in a wedding cake. And they said that all the sustainable development goals are directly, indirectly connected to sustainable and healthy food. And climate smart agriculture can support achieving all those 17 SDGs. And there is another very important goal and agenda, that global food security agenda, which is summed in a SDG 2, and biosphere dimensions, where actually is goals 16, 13, 14, and 15 lies. Actually, it gives, its content supports the social and economic plans. So it actually helps to societal and economic improvement by the define introducing policy. I want to go depth into the goal 2, where in the Zero Hunger Challenge is saying that all food systems are sustainable from production to consumption, and to rural poverty by doubling small-scale producer income and productivity, adapt all food systems to eliminate loss or waste of food, and we have to ensure the accessibility of adequate food and healthy diet for all people all year round, and end to malnutrition in all its form. That means we have to transform our food system, which can help to transform our country as well as transform our world. In another study, where actually 40 case studies have been evaluated, and by the Fascio and TACO, they confirm that the elevated degree of connectivity of power of transmittance of circular economy action in the food system, especially in the favoring business model that affect goal 12, goal 9, and goal 17. So you can see that there are connectivity of all goals with this food security, and ensuring the food security, we have to go for climate smart agriculture, and with the circular economy system. So what are the benefits with the circular economy system? We need to minimize the pollution, climate emission, waste use of raw material. We need to preserve our natural system, which will help to increase the competitiveness as well as create new market and employment opportunities. And at the end, it will provide the social benefits for all. Here, I would like to show one graph. The figure, you can see that in the Central American integration system, they have actually formulated a strategic action where they have shown that all 17 goals are directly, indirectly connected to this climate smart agriculture. There is some heavy litigating framework which actually mention about that the policy changes, government actions and plan all these things in the reducing inequality, ensuring quality education and all these things. But these also connected with the climate smart agriculture. And in FAO, they actually have shown this climate smart 17 SDGs with the linked with the climate smart agriculture, and where, as I mentioned, with the 3 pillars, they said, oh, of course, so there is a linkage with the climate smart agriculture with the 17 SDGs, but there are some synergies. Also, there are, of course, some trade-offs. Trade-off means we need to compromise something to get something from the system. So in the table, you can see the synergies and the trade-off, where this table shows that shared target per SDG for which interlinkage with the climate smart agriculture, also targets of each SDG of which synergies and or trade-off were identified with the CSA pillar and or the CSA implementation process. So there are some synergies with the SDG. There are also some trade-off with the sustainable development goal. So we have to be smart. So I would like to show one example here with the smart IoT-based irrigation and fertilization system. So in this system, actually it collects environmental data from the field, also integrate weather data in them with the weather forecast, and then process the correct fertigation solution depending on the different crops, and provide the different actions from the central control unit. So if we would like to, if we can try to connect to with the climate smart agriculture, before I say, there are 3 keywords with the productivity, adaptation, and mitigation. So use of solar power irrigation, how it helps with the productivity. It increases the yield per unit area, especially during the dry season, ensure income diversification. And adaptation ranges, it actually minimizes water use per unit of product, increasing water use efficiency, resilience to climate shocks. At the same time, it reduces greenhouse gas emission due to reduce of fuel and energy required for pumping and carrying water for irrigation, since we are using solar power irrigation system. So it's increasing yield, increasing water, which saves also increasing income and saves water, improves soil health. So these all those are connected to sustainable development goals. Another example I would like to give is that where we produce huge amount of waste from the agriculture, and net available residue that we have calculated is 61 million ton per year, which can produce 10,000 million meter cube of biogas, from where we can get 19,000 gigawatt hour of electricity per year. And of course, the excess heat can be used for heating the digester or some other purposes. So, so there is a potential of use this waste, convert it to clean energy. That means so to achieve the affordable and clean energy goal SDG 7. I'd like to show another example. In Iran, they are practicing that. There is one of the example, they feed one of the digester per day 12.5 ton cow manure per day, from they produce actually huge amount of biogas. From there they produce actually 1 megawatt electricity per day. Of course, excess heat they use for digesting the heating the digester. At the same time, they produce two products. One is solid biofertilizer, another one is the liquid biofertilizer, which can be given to the field, sorry, or liquid fertilizer with the irrigation system. So if we look at the climate smart agriculture point of view, actually it increased land productivity, product quality and income. Organized fertilizer produced can be used for on forest to enhance the productivity. And adaptation, where what is promoting the use of organic waste, eliminates pathogen, contribute to cover heating needs, reduce pressure on local resources such as timber. Also, it reduces the use of nitrogen-based fertilizer, thus reducing nitrous oxide emission. That is also strong greenhouse gas, and reduce also methane emission from manure and promotes on-farm energy generations. Of course, there is a synergies, there are some trade-off. So there might be the competition between land and biomass production. So if we use land for only biomass production for energy, we may need to compromise with the fruit production. So we have to rely, as for example, for Bangladesh country, we have to rely mostly on the actually waste generating from the agriculture. Another example that I would like to show that we need to also improve our production and processing system by introducing appropriate scale mechanization. Professor Monjurul Alam sir is here, that we are conducting research where we have seen that by introducing combined drying and the hermetic bag, we can potentially save 7 million ton of paddy per year. So it's a huge saving. So that also help to ensure our food security. This is a climate smart way of actually adaptation of climate smart technology in the agriculture, which will help to achieve the sustainable development goals. Another example I would like to give, I would like to show that circularity linked to CSA and sustainable development goals. In the land, actually, if we use the manure from animal, which will contribute to healthy soil and improve crop yield, and the crop that we are producing, 30% of crops are suitable for human consumption. That means unused plant parts can be combined with agriculture and food industry byproduct to produce animal feed. So that can be used for feeding animal. Also, these cattle and sheep can consume grass and herbs in pasture that are unsuitable for growing food, such as peat grasslands. And manure coming from the livestock production system can be applied to the field and which replenishes the soil health. This complete the circular agri-food system. That means we are here with the circularity, we can see that we can efficiently use the resources, we can increase the productivity, at the same time we can reduce the greenhouse gas emission, also to achieve the sustainable development goals. In conclusion, I would like to say that climate smart agriculture is directly or indirectly linked to 17 SDGs. Circular food system need to be implemented which are resemble of CSA for ensuring food and nutrition security as well as achieving sustainable development goals in Bangladesh. Introducing appropriate smart technology along the food supply chain can significantly reduce the food loss and waste. Million tons of available biogenic residue waste can be used for producing affordable clean energy through the co-digestion achieving SDG. At the same time, reducing greenhouse gas emission while adopting concept of CSA or circular food system in Bangladesh. Climate smart agriculture also is an approach often require institutional capacity building and development of institutional coordination mechanism, which can enhance the efficiency, accountability, and transparency of the governance. And research investment and advanced technology sharing for agriculture development through national and global partnership are necessary for ensuring resilient food system in Bangladesh. In remarks, I would like to show that our Honorable Prime Minister said in UN Food System Summit that we quote, we have integrated food system transformation in our national policies and action plan as an integral tool to achieve Agenda 2030, unquote. So that means we are in right track. So hopefully Bangladesh will achieve sustainable development goal by 2030. So thank you all for patient sharing. Thank you, everybody. I stop here.
Thank you, sir, for your nice and informative presentation on climate smart agriculture linked to sustainable development goal 7. Think great, do great. Innovate for green planet. SAIYN is moving ahead with this slogan. Besides, SAIYN has a very strong organization structure for moving forward in a very much systematic way. SAIYN recently organized a logo competition, idea competition. We have 7 more universities along with Bangladesh Agriculture University with this journey. So we hope it will be easier to bring smart agriculture and smart Bangladesh together. We are very glad to have Dr. George Safar within belong us and from University of Illinois at Urbana-Champaign, USA. Now, it's time to hear from our chief discussant. Our chief discussant is Professor Dr. Monjurul Alam sir. Monjurul Alam sir is a professor at the Department of Farm Power and Machinery, Faculty of Agriculture Engineering and Technology, Bangladesh Agriculture University, Manchi. He is a frontier researcher in the field of agricultural machinery and contributing over the years for appropriate scale agricultural mechanization and value chain analysis of agricultural sector. He has led collaborative research with many national and international organizations. At present, he has been leading to Feed the Future USA founded project, post-harvest loss reduction innovation lab, and appropriate scale mechanization innovation hub in Bangladesh. It's my great pleasure and privilege to invite Professor Dr. Monjurul Alam sir for thought-provoking discussions.
Thank you, moderator. Do you hear me?
Yes, sir.
Thank you. Thank you, moderator. I like to thank today's speaker, Dr. Chayan Kumer Saha. because of his thought-provoking presentation on climate smart agriculture and sustainable development goals. We are very lucky that we have our international advisor, Dr. George Safa from University of Illinois, our research partner from PRI, and some other research institute, my colleagues and distinguished guests, and SAIYN ambassadors, members. So I'd like to thank again to SAIYN, as SAIYN has actually arranged this talk, especially have a good importance and relevance to present requirement and needs. So what I'd like to just put some of my remarks that are presented by Professor Chayan Kumer Saha. He has actually discussed about the climate smart agriculture, and before that, he had mentioned some of the climate change things are going on, and that has an impact on agricultural food system and even on our life. And he has related it to climate smart agriculture and sustainable development. So dear participants, what we are actually seeing now all over the world. So even in this winter, in the North America, there was a devastating, snowfall and very low temperature. Even our friend George Sapar, who mentioned that even in University of Illinois, today the temperature is minus 15 degrees Celsius. Again, on the other hand, Europe, where usually temperature in winter usually around 0 degrees Celsius, or sometimes it is negative, but they have feel that there is a warm climate that they have actually engaged, and they have see those temperature rise even in Europe. Even if we see all over the world now, even in New Zealand, there is a devastating flood. And even very astonishingly, what we have seen in the desert of Middle East, in Saudi Arabia, there was a flood. So all these are happening because of this climate change. The global temperature is rising, and especially the UN organization mentioned that there is about 1.5 degrees Celsius of temperature rise on an average all over the world. So we are seeing the devastating flooding one way, another thing is heavy snowfall, or in another way, there is a drought. So these all are effect of climate change. And this climate change affects the agriculture the most. Even we think about Bangladesh, Dr. Chayan mentioned that by the year 2030, the temperature will rise around 1.7 degrees Celsius. If so there will be devastating effect on our cropping system because of the drought, or sometimes it is flood and the cyclone. So we need to cope with this climate change. And even the scientists forecast that if there is a sea rise of 1 meter, so almost 17% of Bangladesh will be underwater. Even if the sea level water rises 0.5 meter, so it has a devastating effect on Bangladesh, especially on the southern delta of Bangladesh. So the saline intrusion will be rise, and there will be heavy loss of crop, livestock, and fisheries. So in these circumstances, we need to think about the climate resilient agriculture. And especially from our point of view, we, the agricultural engineers, whenever we work on the machinery, technology, or other system that helps to enhance the productivity, sustain the productivity of the crop, livestock, and fisheries. So we need to think about those technology and especially the climate resilient technologies. So Dr. Chayan already mentioned that we have been working in the field crop machineries, from tilling to harvesting and post-harvest technologies. Here cite an example. If there is a traditional agricultural practices there, that is from harvesting to storage. So there are about more than 50% losses incurred. On the other hand, if the modern technologies like the climate smart technologies are there, so we can reduce these losses up to 3%. So it will be around 7 million tons of food grains that will save, that we have actually produced, but it is being lost because of this management and practices and technologies. So these are the examples. Now, if we look at the other systems, sometimes we may think that climate smart or smart agriculture means, or precision agriculture means, it should be very sophisticated machines or very sophisticated technology that will be using the artificial intelligence, sensors, and so many things. But just look at particularly 2 years cropping system. So because there are introduction of combined harvester in Bangladesh. So combined harvester harvested the paddy earlier, at least 15 days. So what happened? Because of the saving of these 15 days, now all over the country, what we see, the farmers actually sow mustard seed. So because of this, the war between Russia and Ukraine, there is shortage of edible oil. There is shortage of supply of, the maize and wheat. So Bangladesh is looking for homegrown mustard oil. So because it has been actually happened because we are now introduced the combined harvester in the field, and the combined harvester helps to reduce the harvesting time. So this is the example of smart agriculture, what we have said, that even the precision agriculture. Yes, there are some examples. Probably the students of you have seen that we have established IoT-based solar drip irrigation system. So when we are using the solar drip irrigation system, we have been doing research on these for the last 3-4 years. And we have actually tested it in the southern delta of Bangladesh. Now we have put it into our backyard to see, especially for the students and our colleagues who will be visiting this place and looking these sorts of innovations are there. And these are actually climate smart technologies. So Dr. Chayan also mentioned that climate smart technologies and agriculture that ensures the food security and nutrition security. This is really important now. So what we see that recently our Honorable Prime Minister, Sheikh Hasina, is innovation about transforming the digital Bangladesh to smart Bangladesh by the year 2041. So a few years back, our Honorable Prime Minister, he was trying to digitize the Bangladesh. So now what we have seen, almost all the Pujalas, even in some of these village aggregation centers, there are internet facilities. So these internet facilities, the producers are using it. They are knowing what is the price of a certain produce in the urban market or in the post market. So they can bargain with the paparis and furias, that's the middleman, whenever they are selling their produce. So they will not be cheated from them. So simple, the digital Bangladesh that helps the actually the productivity. As you know, there are some other examples are there. So agricultural support service that based on digital Bangladesh. So whenever someone is facing some problem, they can actually get in this digital system and get help for, especially for selection of the seed or some of this insecticide and pesticide application, fertilizer application, and so on. So these are the benefits of digital Bangladesh that have been already, the farmers are enjoying it. Now, our Honorable Prime Minister is looking for smart Bangladesh. So Dr. Chayan already elaborated the elements and pillars of smart Bangladesh. Smart, that is in smart agriculture. Whenever we talk about smart Bangladesh, the Prime Minister actually mentioned 17-point action plan. And among them, a smart education, smart healthcare, smart agriculture, smart commerce, and smart transport. These are the major points, and some of the relevant other action plans are there. So as we know, if we can actually promote climate resilient technologies, climate resilient production system, that actually ensures the sustainable goal. The main objectives of the sustainable goal is to ensure food and nutrition security of the mass population. Their healthcare, their access to information, access to education, access to finance, access to ensure all of our rights. So as an agricultural-based country like Bangladesh, so we are still mostly depends on agriculture for our supply of food and nutrition. So we need to look at there. Although our present government is looking forward to industrialize the whole country, the government is actually looking for establishing to some extent that is 101 export processing zone. That means in that production export processing zone, all these modern industries will be there. So as you know, the people are migrating from the rural background to those 101 export processing zone. And there is a labor shortage that is seen, especially in the season, harvesting season and planting season. And we have seen there is a negative trend of agricultural labor in agriculture. So it is inevitable that we are actually having mechanization in Bangladesh agriculture, especially in field crop agriculture. We need to look at this post-harvest processing and valuation, as well as livestock and fisheries production and productivity increase and increase the efficiency. By saying so, we need to adapt or innovate the climate agriculture, climate smart technologies, and we need to adapt those things in climate smart agriculture. So as agriculture will advance, that will ensure of the country and sustainable goal developed by UN. So with these few words, I like to thank SAIYN for arranging such important discussion today. I'd like to thank Dr. Chayan for giving a very excellent presentation. And I'd like to thank all the participants, especially Dr. George Safar, our friend from University of Illinois, although it is very early in the morning, but he joined us, he encouraged us, and especially he encouraged the SAIYN members. I'd like to thank him and thank you all for patience hearing. Thank you.
Thank you, sir, for giving your valuable and a very sharp reactional space. It will help us for moving forward our thoughts with this platform. Now, we will go for the question. Our valued speaker and discussant will provide his answer if you have any question. Dear participants, please use chat box or raise your hand if you have any question to our speaker and discussants. You all can ask questions to our discussants and our speaker. The open is floor. Floor is open.
You can just unmute and you can talk. No problem.
Dr. Chayan, Dr. Saha, thank you very much. It was very interesting. I always learn something when I listen to you, and I appreciate all the work you do. It's very impressive to see Bangladesh leading this effort. And I look forward to the future to see what brings, because you're clearly in front of the world as far as what you're doing. So thank you again. It was great.
Thank you, Dr. George. Thank you very much.
Lucky, I want to say some words.
Yes, sir, please, sir.
Okay, thank you. At first, I would like to thank the SAIYN for arranging such a wonderful seminar in online platform. And I also would like to thank you so much to our today's keynote speaker and discussant for conveying the wonderful message among the today's participants. I hope all the participants have got the great information from this presentation. According to our today's keynote speaker, he has already mentioned that existing linear agriculture production system contributing 39% greenhouse gas emission. It is really great or significant amount, and also alarming so far, I think. I would like to say it is necessary to convey the circular agriculture system or climate smart agriculture system among the policy level or researcher level, who can take the further policy so that we can get the smart agriculture, and that will reduce the greenhouse gas. And I hope this message also convey to our today's participant, and it will definitely create new dimension in our next generation, and they will contribute the new research, and hopefully we will shift to our circular agriculture system, and that will reduce the climate smart. That's all about from my side. Thank you for a nice program. Thank you.
Thank you, sir. We have a question, and that is, we are student of agriculture engineering, what should we do? What should we do to implement climate smart agriculture? I would like to invite our honorable speaker and discussor to give your valuable opinion.
Thank you, Lucky. Actually, this question came from Tanbirul Islam. It's a very nice question. Actually, you know, there are few buzzwords there in the climate smart agriculture. That is increase of productivity by increasing resource use efficiency. So that's the word you see, that where we need to act, we need to work by our smart application of smart technology that our Prime Minister is saying. So as for example, I have shown that with the using of combine harvester, with the using of drying and storage, we can reduce or save the production, at the same time increase the total amount of food. On the other hand, another example I have shown, that using the smart IoT based irrigation fertigation system. So that means what we are giving nowadays, maybe we are wasting, because you see, if we were giving flood irrigation, we may not, probably don't need to give this flood irrigation system. Depending on the crop, it may vary, but if we can optimize the water input, if we can optimize the fertilizer input, sprayer input by introducing kind of smart sprayer technology or sensor-based technology, because this kind of sensor-based technology helps to provide, actually provide the information. By this information, actually our technology can act and provide the input to the crop or are in the processes. So this is something that where we need to think of, our agriculture engineer need to think of this circularity, climate smart agricultural system, keeping in mind the sustainable development goals. So Professor Monjurul Alam sir is here, he may add something there. So
Thank you, Dr. Chayan. Yes, I'm going to add only a few things. You look, whenever you see or say agricultural engineers, so there are other engineers, like the civil engineers, the mechanical, electrical, electronics, computer engineers. So what are the differences between this agricultural engineering or engineers and the other engineers? This is really important. Rather, I can say there is a big difference between agricultural engineering and other engineering. With agricultural engineers, we always deal with the living being. Whenever it may be crop, it may be livestock, it may be fisheries. A plant is growing, the plant is a living being. So like, you know, these construction materials like the brick, the timber, or the wood, the steel. So their properties are defined. But when you look at this living being, they are actually very, very special. Care is needed to define their properties. Each actually directly acts with the environment. That is really important. So whenever we are working with growing the crop or the livestock or the fisheries, then we have to think these are the living beings. So the environment and the whole ecosystem is really important and affecting on them. So whenever we are innovating a technology or adopting a technology in this sector, especially for the living being, we need to be very sensitive. So agricultural engineers are actually by training have to have that capacity to deal with this living being. So whenever we are actually going to innovate a technology, we need to think, like Dr. Chayan already mentioned, in the case of applying of inputs like irrigation, fertilizer, seed, or insecticide, pesticide, whatever it may be. So we need to put these inputs efficiently. We need to manage the whole production system efficiently. And that is congenial to growing for the living being like plant or animal or fish, and increase the efficiency of the production. That is the total productivity system. So whatever may be the innovation in terms of machine, in terms of technology, if we keep into the mind, then we need to know ourselves in which area we are putting our intellect and putting something new. I like to mention another very small thing, you know that if you look at the industrial revolution, so we are at the advent of fourth industrial revolution. So the first industrial revolution starts with the innovation of steam engine. That was during 1750 to what it is 1870. But the second industrial revolution starts with this innovation of electricity, electrical motors. When you use it in agriculture, use it in the industry. And the third revolution starts with the innovation of computer science and IoT, that is information technology and the Internet of Things with the computer. So the sensors are coming, some sorts of automations are coming into industry as well as agriculture. But from the 2010 and onward, there is the era of fourth industrial revolution. What we actually define it as the era of artificial intelligence, along with this IoT, the blockchain, nanotechnology, and so many things, the drones and everything what we are talking. So all of the things are there, but we are still actually lagging behind in agricultural sector, in agricultural mechanization. We are still at the second to third industrial revolution. But the whole world will not be waiting for us. So we have to give a way to catch them. So we need to introduce the technology with some sorts of sensor-based technology, digital technology, as well as the most recent artificial technologies. So we need to combine these things as agricultural engineers and apply it to the environment of living being development, that is the plant, livestock, and fisheries. So agricultural engineers have the opportunity to contribute in the whole, what I said, that climate is resilient agricultural system. And that is the base and foundation of the sustainable development goal, whatever we call to this. So what I say, the agriculture engineers has the great opportunity to contribute in that way. So that I like to add. So thank you.
Thank you, sir, for your valuable opinion. We have another question from Nibir Kanti Roy, and that is, as climate smart agriculture and its popularity is getting an inevitable thing to attain the sustainable development goals, our academics should include it on a large scale. But when we are continuing to our study, we get very less exposure to all of these advanced and smart technologies. So what could be the solutions so that our academic curricula meets the advanced technologies and innovations in agriculture? I would like to request our keynote speaker, Dr. Chayan Kumer Saha, sir, for giving his valuable opinion.
Thank you, Lucky. Actually, it's very interesting to see that our students are reacting and asking questions, and it's a really very relevant, and it would be good that if all you know that what we are doing for changing our course curricula with that current context. Actually, probably you know that we have already changed our course curricula, adopting all these electronics, robotics things into the in our agriculture engineering degree. Especially the new enrolled student from the last year, they have started to take those courses. But those who have not chance to take this course, you may think of using this technology into the research. Our actually academician, our faculty members, they are very keen in that. We are very always ready to help you all regarding these smart technologies. On the other hand, there is actually oceans of knowledge in the web-based platform. So you can also explore by yourself to learn more on those technology that might help you to actually enrich your knowledge and apply that knowledge into the agriculture. I would like to answer another question that was asked by the Raju, actually how SDGs are work in Bangladesh. Actually, you see that that government has already actually 5 years plan, also SDG plan, as well as 2041 plan, Delta plan, everything. And our institution is actually changing accordingly, acting accordingly, and giving those kind of research. As for example, Dr. Ayub Hussain is here from Bangladesh Agriculture Research Institute. I know that they are already working on the 4IR technology adoption in agriculture. So government is working. We are not far behind. Just I showed the one quote of our Prime Minister. We are actually thinking far ahead than others. That before we talked about the digital agriculture, now we are talking about the smart agriculture. So when our Prime Minister announced that all the institution has started to think about the smart agriculture, starting to apply the smart agriculture in all aspects, as Professor Monjurul Alam sir said, that smart in agriculture, smart in industry, smart in education. So in every case, so we are trying to apply, and we have this very good platform of 5G technology. So this is something that we are not far behind. So hopefully we can really achieve, and everyone actually all other countries are looking at the Bangladesh now, that how Bangladesh is changing with this all those defined actions for achieving sustainable development goals. So that was from my side. I don't know whether Monjurul Alam sir would like to add something there. And there is also one question is, what is reduction in inequality?
Yeah.
Maybe sir can answer that one. So.
Thank you, Dr. Chayan, and thank you, the students who have raised those questions and concerns. Yes, we are changing. As you see, the faculty that we are recruiting, especially in the Department of Farm Power Machinery. In our department, we have agricultural engineers, we have mechanical engineers, we have electrical and electronics engineers. Now, particularly this year, we have recruited mechatronics engineers. And as Dr. Chayan already mentioned, that we have already changed substantially our course and curricula, and especially the new student who will be enrolling and learning those courses and curricula, that has been changed. And what we are talking, we are trying to align these ideas into our course and curriculum. But one thing is we need to remember, in Bengali, we call Shikkito Manush Manei Shashikkito Manush. That means whenever you need to be educated, you need to be educated yourself. So as Dr. Chayan already mentioned, there is a horizon of knowledge. Now it is open to you because of these digital platforms. So you have to build yourself. Even in undergraduate or master degree course curricula, only the fundamental areas and fundamental knowledge that we can actually render to you. Even we have some limitations of resources, especially in the physical development of the labs and even the physical resources that need to be offered to the students. But as there is a virtual platforms are open, so I will ask you to just utilize this virtual digital system, as because now the whole world is a global village. So if you want to work in anywhere in the world, you need to just put what are the qualities you need to improve by yourself. So you have the basics, and especially the agricultural engineers has the opportunity to have a diversified basic knowledge within their course, inbuilt course. So if you want to develop yourself, you can go through by learning and by doing and exploring the digital platform, you can reach and you can have that skill. This is very important, and that sorts of opportunities are there. Even what we are doing nowadays, even in the research, a certain portion of is absolutely engineering, but we are now doing some of the social studies, some of this, this value chain and other studies that is not directly related to engineering. But if you look at this, the value chain expertise all over the world, 50% of them are engineers, not the economists or social scientists. So engineers are smart, they can develop in any area, and as they are tidy in their work, they can be a successful practitioners in any area even other than the engineer. So what I say, every man is self-built man. So you have the basics, We have some limitations in resources, but the horizon is open. So you can go ahead and keep yourself, okay, keep it in yourself, what you want it to be, and be that. And that's my actual suggestion for it. Thank you.
Actually, regarding the inequality, that something Shobuz
Yeah,
Borgon
I
asked,
missed.
so
I
maybe,
missed.
sir, yeah.
So in terms of inequality, yes, this is the big issue, and it is all about the world. What I usually mention, the two things actually change the whole human society of present day human society. One is the Industrial Revolution, another is the French Revolution. Industrial Revolution gave us the boost of use of science and technology, and especially the technology in production system. But on the other term, that is the French Revolution, that gives us the perception of equality and eradication of inequality, what we call that's the freedom, the human rights, the women rights, and so many things. So those phenomena are not very old. We are still struggling in establishing this equality within our democratic society. Even this society has limitations, especially the access to information, access to healthcare, access to education, access to economic emancipation. These are, although it is actually narrated even in our Constitution of Bangladesh, but even whenever we are going to practice it, there is always some limitations. But as a front-runner citizen of Bangladesh, so we have this actually what we call that responsibility to offer those values and raise our voice and concern wherever we work and wherever we do actually raise voice to against those inequality. And whenever we work within a system, so within a system, we need to work on that. Just one example, when we actually develop this National Agricultural Mechanization Policy, I don't know whether you have this opportunity to go through it. It is now in the website of Ministry of Education. If you look at those particular policies, if you read it carefully, you always see that there is a provision always there that at the bottom line, the farmers, especially the resource-poor farmers, they haven't left out. So that whatever incentive or whatever some sorts of this help from the government going to the farmers, that should be up to that level. But still, there are some limitations. So what I actually request, it is our responsibility and your responsibility also to raise our voice, and whenever we work, we need to keep into mind that any policy, any strategy, any implementation that doesn't exclude, especially the resource-poor people, especially in our case, the resource-poor farmer. So thank you.
Thank you, sir, for your valuable answer.
Assalamu alaikum. Hello, Assalamu alaikum. I am Budrul Islam and I have a question.
You can ask.
Okay, we all know plastic pollution, so how damaging it is for the environment. So as an agricultural engineering student, how can we deal with that, or what should be our thought process towards dealing with the plastic alternative biodegradable solutions?
Actually, Budrul, it's an interesting question. Actually, we are not actually sitting idle. other scientists in agriculture working on biodegradable plastics, especially in the Jute Research Institute. But there is also options of recycle these non-degradable plastics. As for example, if we think of smart city, if we can actually segregate this plastic at a source or in the collection point, we can actually reuse those, make a mold of plastics and reuse for other like making toy making or some other purposes, or making a kind of a small linen what it's called, the product. And also the things actually always we have to think of a different way of using how we can reuse this waste for making it more environment friendly and reducing greenhouse gas emissions. So you are having a knowledge of kind of mechanical engineering, the blending of electrical and chemical engineering. So probably you have to think of, many scientists are working on actually converting plastics into the biofuel. So there are many options. So probably these are the things probably we have to think of. So options are there. We have to try and make it more sustainable. So thank you.
Sir, assalamu alaikum. Sir, I have a question.
Yeah, please,
Sir,
sir.
I'm Abdullah Kafi.
Please.
Sir, in my village, we face the farmers are facing some problems about machines, and when they face this, they ask me what are the solutions about this problem. But I have then no idea about this question. There's in field level, our machines are facing different problems, but in our laboratory or in our education, we feel some problems, sir. So how can we answer this question, sir? Please, if you help me.
Yeah.
So thank you,
Kafi,
sir.
yeah, you have raised a question. What I mentioned, earlier, that whenever we teach in the classroom, we always talking about the very fundamental basics. So if you want to know everything in 4 years' time in undergrad courses, it is never be possible. But as you know, even if you look at the machine, and if you can like to have the manual of this machine, you can have in the digital part. So the very thing is, the fundamental thing is, about a machine, how it works, what are the systems, or to some extent, some repair and maintenance schedules, etc. But in the case of troubleshooting and others, even if you go through your textbook, you can find the answers in general. But in a specific, if you download that particular manual and go through it and try to resolve the problem, you can be able to resolve that problem. So now you have an educated person. You know how to go through, attack a problem, and how to resolve this problem, and how to have the solution of the problem. So what I actually suggest, even for an example, when I actually graduated, so, and being a lecturer of this department, so all these machines in our engineering shop, only few of them we have operated during my studentship. But when I became lecturer, the first thing I did, so we have done a very good mechanic named Aziz Mia. So I just went to Aziz Mia and asked him, okay, before, at least 15 days before I started these practical sessions with the student. Okay, Aziz Mia, teach me. I have learned it. Most of the thing I have forgot. So I want to learn again. So I have done it myself. And Aziz Mia with me for the first year, I have to learn all these operations of all these machines, and hopefully nowadays it is, I do not actually teach those workshop technologies and other things. But the older student actually know that whenever I'm in the practical class, I usually demonstrated it myself. So this is the way you have to learn. So you have to learn by yourself. So what I suggest, although if you go through your textbook, you will find a lot of answers or a specific solution. Just download those manuals of those particular machine and go through it. So all sorts of maintenance, troubleshooting, and others are given for the specific machine in those manuals. So you can resolve it and you can answer these questions. This is the way. There is no shortcut way. So we have to work hard and we have to acquire knowledge and skill for ourselves and solving the problems at the field. Thank you.
Just to add, Professor Alam, actually, Kafi, it probably the things that don't suggest anything what you see in the lab, suggest something that you see in the field, and you need to keep your eye open actually before suggesting to farmers whether it really work in the field or not. As for example, our BUST took 8 long years to reach to the farmer. So this is something that probably you have to always think of. You have to be very smart. You are engineer, so farmers will come to you and ask you about the appropriate machine. So you need to keep your eye open. What are the machines are available now in the field, offering by the industry or companies. So that's something probably you have to keep in mind. But don't suggest anything what you just see in the lab. So it's a kind of, it might be in the research lab level or in the very first phase of the innovation level. So that's something you have to think of and look at. So.
Thank you, sir, for your resourceful work. I would like to thank respected advisors, mentors of science, chief ambassador, seminar ambassador, and others for arranging wonderful session. Thank you everyone for joining this seminar and investing your valuable time. We hope it's the starting of a new journey. We will go really far with your participation in the events arranged by the SAIYN in near future. We also hope that we will meet again to execute our next thoughts and plans. Till then, keep your surroundings safe and be safe. Thank you everyone. Wish you all very good night and good day to our guest from USA and goodbye from my side.
Thank you.
Thank you all. Have a good day and
Thank you.
good. Yeah.
Thank you. Good night.
Bye-bye.
Thank you. Thank you.
Thank you, George. Have a good day.
Thank you all.
Thank you, Dr. Alam. Great to see you and Dr. Saha again. I'm very encouraged that you had over 90 participants. So we sometimes get discouraged about the climate and the damage we've done to our environment, but by seeing these young, smart people, I think I'm very optimistic. So thank you for all your work. It's great.
Thank you. Thank you. Stay safe. Bye.
Okay. Bye-bye.